So let me summarize this. We are having an hour-and-a-half session. So we will do this on 3 separate sessions. That is for the recording purpose. Also, Zoom have some kind of limitations. So what we do now is that we start a session. After half an hour, we will close. We will open the same session again using the same link that we used to enter for Zoom. And when I upload all the video files that I will share with you after the session, then you will find them 3 separate video files for our class. Okay?
Okay.
Good. So we will repeat that all over the classes. And this is the same with all my other students. We always have 30 minutes sessions that is divided with whatever content we have inside. On every part of the class, on every session, as we said, we have 3 sessions. So I will divide and I will mention whatever was mentioned in that specific session, what is the content, and based on that, you're able to separate sessions into 3 halves, or you choose which session you want to listen to or re-listen to, or and so on. So is that clear? Toju, can you still hear me?
Yes, I can.
Okay, perfect. So yeah, let's start. So last time we talked about machine code. So the introduction I'm giving to you today actually is just a basis for you to put you to understanding of what we are going to do with actually designing and coding programs, simple programs. Okay, so I would say that very little chance that you will have too much questions here on the exam, but this is just a basis to put you in a level that you can understand what we are going to talk about. So mainly we need to be able to come out with a conclusion or with the knowledge that we can code in pseudocode or we can code in Python. Okay?
Yes, okay.
Good. Okay. So can you still remember anything we talked about machine code? Does this still stick to your mind or no?
From
the last session, yes, the first trial session.
like
Yes.
low-level languages.
Okay. Yep. Okay, that's correct.
Okay.
So
So that means good.
okay, so questions is important during our class, because when I ask you a question, actually I'm triggering your mind to think, and things will never stick to your mind unless you try to recall it back from your memory. So it's not much that I'm testing your abilities, but it is more that I'm triggering your mind to think and try to get whatever information that you have. And based on that, I will take decisions to what to stress on the session and what not to stress on. So if I see that maybe there is the information does not stick yet to your mind, so I will put more stress on that during the session. So it's not much that I'm testing your abilities. So don't take that as that you need to worry about that. I'm just testing how your mind recalls the information from your brain, and if the information is already there or not. Based on that, I will take a decisions. Okay? So no need to worry about that at all. Is that clear? Toju, can you still hear me?
Yes, I can.
Okay, perfect. Okay, so can you still recall any of that we talked about last time? So maybe we didn't talk about machine code, but actually we talked much about little bit about assembly here.
Yes.
Okay, so if we want to say what is more close to the hardware, do you know what the mean hardware?
Is it the physical components of a device.
Yes, exactly. Yes, exactly.
Okay.
So that physical part of the devices, it needs the software to be able to operate. Okay, so it only can operate machine code. Okay, it only can understand ones and zeros, nothing more. It cannot understand that. Okay, so whatever we write, whatever code we write, we need a way to translate from whatever language to always have a machine code. So if we write in Python, we need a way or a software in the middle to translate whatever we write in high level language into the machine code, because the machine or the hardware can only understand ones and zeros. But we as a human, it is very hard for us to understand that. Okay, that is somehow cryptic to our minds. We cannot recall that ones and zeros. So that's why these come up with languages that is more readable to the human, and then they use a software in the middle. Okay, we will come up to see what is this software called, and this software, its only purpose is to translate from what the human can read into what the machine can understand and operate. Is that clear to you?
Yes.
Okay, so Toju, I will start this session slightly slower than usual, and then but I will ask you from time to time, do I need to increase the speed? So you have to
Okay.
adjust. Let me adjust the speed. If I'm slower, then we can move faster based on your preferability. Okay. So Tojo, can you guess to me the program on the left hand side? What it do actually? What is the purpose of that 3 lines of code?
Um, I
Tojo, I didn't hear you very well. Okay, do you mind?
sorry. Um, I think the third one, SDO, might mean to store something in a variable, maybe.
Yes, yes, yes. It's good. Okay, so that the first one looks like loading something, LDA. Okay, the second one, it's like adding, maybe it's adding maybe 2 numbers because we cannot add only one number, right?
Yes.
And the third one is storing a number, like, so looks like we are storing something. So LDA, it is doing some operation on a variable called first. And the second add command is dealing with or doing some operation on a variable called second. And storing is actually having some operation on a variable called sum. Okay, do you know what the meaning of variable?
It's like it can be changed throughout a program. It contains value, which can be different data types.
Okay, let me define that in a better way. We say that a variable is a place in the memory, in the computer memory. So do you know what's the meaning of RAM?
The storage that the computer has for.
Yes, perfect, perfect. So we have two different type of storage, right? You know, we have RAM, and this is a volatile kind of memory that if we remove electricity from it, it will lose all its content. Okay, and we have hard disk or permanent storage. That permanent storage, even if you remove electricity from it, it will still keep the information inside. Is that clear? Tojo, can you follow?
Yes,
Good.
I can.
Okay.
Yes.
So when I said a variable, and we will be always talking about memory, RAM, not the permanent storage. So
Okay.
if I want to say I am storing a variable, I would say that I am reserving a place in the RAM, in the memory RAM, and that place I will give it a name. Okay, so that place in the memory will have an address, same like our houses have an address, and it will have a kind of same, every house have a number, right? So we will also say that the variable have a number that can locate its exact position in the RAM. So normally the RAM, it is, let's assume that it is this kind of arrangement, just for ease of understanding. And also for kind of simplicity, I will just say that, okay, this is the first position, this is the second position, and this is, so it is always started from 0, and there will be spaces here arranged in the RAM that for us to store information inside. So this is normally the addresses is slightly complex than that. So it's normally take this kind of form, but for case of simplicity, I'm just giving it from 0 until 3, just for case of simplicity. So that is a place, I would say that, so that is a place in the memory that I can take to store a variable called first. So I will put that, I will reserve that place for the variable called first, and I'm able to store information here. It can be a number. For example, let's talk about number because we didn't talk about any other kind of variables. So I can store 10 inside. I can put 10 here. Okay. So now, if I want to do any operation, if I want to tell the program or the computer, please get me whatever inside first, he will go and get me 10. Because I mark this place in the memory that it is store a variable called first. And what is inside that variable? We storing 10, an integer of value 10. And then I will say that the second place in the memory here, I will make it for storing a variable named called second, because our memory brain cannot recall this kind of arrangement. So that's why they come up to us that we are able to name memory addresses with names that is readable to the humans, like first, second, some. This is more readable to us than this kind of numbering. And when we have a program that have 20 or 30 variables, we cannot recall 20 or 30 memory places with this kind of numbering. It's very hard for our brain to remember that. So that's why we need to call memory addresses with numbers like that. And later on, we will not talk about that at all. We will never mention that. We will only talk about that we have a variable, and then whatever operations the compiler or the things that we are using to write the programs will handle all these kind of memory operations to us. We will never have to talk about that when we are writing Python or we are writing other high-level languages. Okay, but this is only now for the sake of understanding. Okay, are you able to follow what I'm saying?
Yes, I understand.
Okay, perfect. And then we will store a third variable in a different place in the memory, and we will call it sum. So actually, the purpose of that program in short is to add first whatever in the first variable. So if you would put here 10, then we will add 10 to whatever value we have in the second. Let's say we have 100, like that. And we will store the results in a place called sum. So if this is the place of sum, we will put here 110. Does this make any sense to you?
I understand.
Okay, so we are able to move from here? Can we?
Yes, we can.
Okay, that's good. Should I increase my speed or that is fine for the moment?
It's fine for the moment.
Okay, perfect. Good. Okay. So have you seen Scratch before?
Yes, I have.
Okay. Did you do any programming with Scratch?
When I was younger, yes, but not
Okay. Okay.
much.
Perfect. So it is, you know, that it is just a block-based programming. And here we are not dealing with it. He just mentioning that this is a type of block-based programming that they teach children how to deal, how to start programming with. Okay. So let's talk about here. Actually, so the assembly code that we talk about, he's telling us here why we need to use assembly code. So assembly code is it's not used too much at the moment, unless we have um, some kind of small hardware that we can put that we use in maybe a washing machine. We use maybe sometimes maybe we need to use in a game, small toy, complex toy. So this is a kind of places where we might need to use assembly code at the moment. So assembly language is rarely used at the moment. Last time, 20 years ago, it was very common to use assembly code or assembly language. So um, assembly code is not hardware specific. Machine code is, how to say, so for every machine, for every hardware, so the machine, the hardware that we use inside the washing machine might be different from the hardware that we use for the refrigerator, might be different from the hardware that we use for the TV. Okay, all have different hardware, and all of those have their own specific machine code. You still remember how the machine code looks like?
I do.
This is the machine code.
Yes.
Okay, so every one of those have different machine code. Okay, but the assembly language actually make us they make a layer easier for us, so we don't need to worry too much about what machine code work with which hardware. What we need to do is that we just write the code in the assembly language, and whatever software or interpreter or compiler in the middle will take our machine code or assembly code and translate it to the machine code that the hardware, that specific hardware can understand. Did I make myself clear here?
Yes.
Okay, good. Okay, so yeah, what we want to say that we use assembly code when we have limitation in the memory, when we want to something that we want to write a code that run very fast, because assembly code run much faster than Python, than Java, and than other languages. And it doesn't
Okay.
take too much space in the memory, and it runs very quickly. Okay, is that clear to you?
Yes, I understand.
Okay, perfect. So, okay, here actually we did explain that this is adding two numbers, first and the second, and this statements is written in assembly language, and it stores the result whatever in the first and the second, and it's stored sorry, here maybe it's not very clear to you. Let me See, okay. So we store the result in the sum. We already talked about that. So here we can, yeah, okay. We move to the next, yeah, and that is also, so let me, even though that's not very important that you understand that, but let me put it here. LDA means load the value of the variable, in this case first. So at the moment we just said it is 10, okay, just for example, okay, into the accumulator. So the accumulator, when you look at the hardware part or the serial part, he explains more about the content of the computer and the central processing unit. So that is a part of, so let's assume this is the processor, okay? So certain places in the processor we are able to use in a calculation, and the assembly code LDA is actually dealing directly with accumulator. So accumulator is a place inside the CPU unit or the processor unit. Okay, processor unit is a hardware, it's a piece of hardware that is actually executing, is responsible for executing the instructions of the software that we write to it. So even the operating system, the Windows, and yeah, so I think you didn't experience something before Windows XP, right? Did you experience Windows 98?
No,
Only
no, I
maybe
didn't.
XP, right? The first thing that you have seen, XP or maybe Windows 7?
I think Windows 7.
Okay, so yeah, okay. There was before, there was Windows 3.1, then Windows 95, then Windows 98, and then Windows XP. It took some time in the market, and then after that, they moved to Windows 7. That's the first thing you saw. And before even the first Windows, there was something called DOS. Did you hear about DOS before?
No, I haven't.
Okay, okay. So that's kind of a black screen when you have to type all what you need from the computer using codes, using commands. Okay. Did you deal with Linux before?
Pardon?
Linux.
Yes, I know it. Linux, yes.
Okay. So DOS is somehow similar to Linux, that in that for the computer to do something to you, you cannot just use the mouse and click things. Then you have to much use the commands. Okay. Linux do have GUI that you're similar to the Windows, but it is more stronger on the command side. It have a strong commands that you can do a lot of things using the command. Okay, let's go back here. Let's stick to our what we are saying here. So again, the CPU is a place in the memory. It's not, sorry, place in the computer that is responsible for executing the commands that we give. The commands can be something like that. This is considered a command. Sorry. So that is LDA. It loads whatever in the variable first. It load it from the RAM and put it inside the processor. But inside the processor, we have something called accumulator. Okay. So it would put it there. So normally, most of our commands have to deal with things inside the accumulator. Okay, so here on the second line, add, it take whatever inside the variable second and add it to whatever stored in the accumulator. So here is the memory. We have places like that. We said before, we have 10 here. We have 100 here. Okay, this is the first variable. This is the second. This is the second variable. Okay, and this is a sum. Let's put like that. Okay, so we will always, to be able to to do some operations on our variables that is in the RAM, we have to move it to the, let's say here is the processor. Okay, so this is accumulator, ACC. That's a special place inside the processor. And to do some operation, like I said, so first we will load first here. We will put it here. And then the second, I will tell get whatever in the second variable and add it to whatever in the accumulator. And then the third command, replace the variable, the value of the variable sum by the stored, whatever stored in the accumulator. So the result of the addition that is stored in the accumulator, I will take it, I will store it here. And there you will be able to find the result, which is 110, the addition of whatever in the first and the second variables. Does this make sense? Is it complicated?
Yes, I understand.
Okay, perfect. Is it hard to understand?
No, not really. No.
Okay, good. Okay, so we have two kind of software, pieces of software that help us. One that is called assembler, and another one that is called interpreter. Interpreter is not as common now. Maybe I'm not sure if you heard about a language called BASIC. Last time, previously, 20 years ago, people tend to use a BASIC language and also maybe Fortran. I think when I talk to your mother, also she still can remember this kind of languages because at our times, this is what we study. This kind of language, they use something called interpreter. It's much simpler in its abilities compared to Python now. Okay, and even there is a lot of codes that is written for banks and the big computers that is used in the banks. They still use the basic language. So now we have to close and we start. We click again the same link of the Zoom to enter a new session. Okay. Is that clear?
I understand.
Okay, perfect.